Hello, and we're back. So this is an important chapter. I've already mentioned intelligence testing, um, I believe, and it's pretty clear to me that your author has read one book on the topic that I've read. I recognize several fragments of the chapter from that book. So the opening vignette is about Crichton, the butler, who on a desert island becomes the leader of the pack. But then he has to go back to the homeland, and he isn't. The British were very, very class conscious, and perhaps they still are. I'm not amused by the concept. Um, Intelligence, and of course, if there is such a thing as intelligence, and virtually every culture um, believes that there are differences in how functional people are on areas relating to intelligence and history and development of intelligence tests. The Chinese were using tests to check on whether people should get government jobs long before the stories that are told here. Sir Charles Galton, distant cousin of Charles Darwin, Nature Nurture, he was convinced that intelligence was heritable, and certainly to some extent it is. And he certainly tried to measure intelligence, but never came up with anything that was overly functional. Now, the French government asked Alfred Binet to find a way to assess whether school children could profit from a normal education or not. And certainly, I think it's more ethical to have standardized tests that can identify children who need a special learning environment rather than throwing them into a classroom for 1, 2, 3 years until they've learned that they can't function and their little peers are tormenting them. So I think that this was an ethical thing to do. And since he was focused on children, Binet and Simon, they knew how old the children were, the chronological age, and he developed a test to assess, mental age, the and standards that this is what a 5-year-old, a 6-year-old, a 7-year-old should be able to do. So Binet Simon, 30 different tasks, and there are some of them. And by the way, I think the Brits are taking what's in B out of classrooms because children today can't tell time using that device. And the Binet Simon gained reputation, and Lewis Terman, very famous psychologist, Stanford, translated it and established the Stanford Binet test. And here we are going into World War I. And once again, we want to know who would be good at different kinds of tasks. And they developed the Army Alpha, which was written, which is what you're looking at in that picture. You can see that that's not a very well-controlled environment, although I guess it's controlled because people are standing over you, ready to yell at you. Army Beta was for incoming soldiers who couldn't read. And IQ, intelligence quotient, which we still use the term today. We don't calculate it this way anymore. The ratio of mental age divided by chronological age times 100. And there are examples of calculating it. And down the bottom, there's a table of numbers that shows how it turns into numbers. The Wechsler is quite famous. Wechsler Intelligence Scale for Children, WISC, 6 to 16. Some of you maybe have taken this if you were tested for gifted programs in grade school. And there's also the WAIS, the Wechsler Adult Intelligence Scale. There's a picture on the next page that still sends chills to me. My ex-wife was a clinical neuropsychologist, or is a clinical neuropsychologist, and she had to be certified at administering the WAIS, and that's one of the elements of the test. And boy, I did not want to be tested. I didn't want to know, but she needed a participant, and I was about it. And I remember assembling those blocks. Things were extremely standardized. If you're taking the SATs or ACTs, those are very standardized, and they now are not, a ratio of mental and chronological age. They're normalized against a reference population, and statistics are about to come into our lives here in a bit. And there's Wechsler and how it's administered and standardized and normalized, and percentiles. So when you took the SATs, almost certainly you can remember what percentile you were in. And of course, you want to be in as high a percentile as you can. And there's a table, different scores on the SAT, and what that score on the subscales, critical reading, mathematics, and writing mean in terms of percentiles. This is the way we do it these days. We don't do the ratio, but we've retained the name because people are comfortable with it. Normal distributions. I've gone to science museums, and Galton did this in his displays and tests, where he was trying to figure out tests for intelligence. But the bean or ping pong ball is what I've seen. They come in from one place, and then they hit the pins, and they hit the pins, and they hit the pins, and you end up with a normal distribution. It's if you remember back to the statistics chapter, normal distributions are symmetrical, and the three measures of central tendency, mean, median, and mode, are all in the middle. Life is good when you have a normal distribution. But then you need a measure of dispersal around the mean. And what's commonly used is the standard deviation, which is the average amount that each individual score falls above or below the mean. And no matter what you're measuring, ping pong balls dropping on pins, IQs, number of apples on a tree, as long as it's normal, this is the way the numbers shake out. And that allows you to compare apples and oranges in a sense, because the percentage of the distribution that falls above and below the mean by standard deviations is consistent. So, of course, if you're at 100 on the IQ test or whatever the mean is on what you're measuring, you're at the 50th percentile. But if you're one standard deviation above the mean, and in this example, the standard deviation is 15, you take the 50, you add 34, so you're at the 84th percentile. If you throw another standard deviation in, you add less, 14%, and 84 plus 14 is 98, and you're at the 98th percentile. I remember giving a lecture to, I think, high school teachers in the city of Scranton, and we were discussing the gifted program, and they said, well, to get into the gifted program, you have to have an IQ score of at least blah. So they gave me a number. And I said to them, well, what's the standard deviation on that test? And boy, none of them had ever heard of that. It's common to require 2 standard deviations above the mean to get into gifted. It's not so in this example, since the standard deviation is 15, it would be 130. And then we have achievement tests, and you've been tested on something, there's no doubt about it. The concept of reliability was discussed in the statistics chapter. If you don't have reliability, you really don't have anything. There are different ways of measuring reliability. Test retest, you do it twice. And on the left, you have garbage. And on the right, you have pretty good reliability. Scoring reliability, the extent to which 2 different scorers report the same score on the participant. Inter-observer reliability and inter-rater reliability are very important and are used in psychological research quite a bit. Split half reliability is certainly done. You take the test and split it in half and calculate performance on each half. It's not uncommon to do odd, even, split half. I see we're getting some weather here. Hopefully my power won't go out. And cross-test reliability. If 2 tests are supposed to be measuring the same thing, you should get approximately the same score. So there's an example of scoring reliability, split half reliability, cross-test reliability, where they're comparing Stanford-Binet and WISC scores. You can see there's a ton of science in here, and it goes back decades. This is a solid area. It's something I do believe in. It's not perfect, but it's way better than just throwing kids into classrooms. And it's like telling if someone's a witch, you throw them in water and see if they sink. There's validity. Does it measure what it's supposed to measure? Construct validity is classic. And you have different tests: convergent reliability, content validity, criterion related validity. They're all very important. They've been studied for decades. IQ tests work pretty darn well. Not perfectly, but pretty darn well. So there's a table that overviews the three: Stanford, Binet, and WISC, similar scores. Does the test cover all aspects of the trait? There are definitely debates on that, and there's a famous Scrantonian who's involved in that. I'm not a big fan of what he has done. I saw him speak. He spoke on campus a couple of years ago. Does the test offer any statistical predictions about real life performance and performance in school, workplace? And the book that both your author and I read dealt with all of those things. Large samples are important, correlations are important, and refresh your memory there. If there's no correlation between two variables, the correlation is zero. And of course, if you have as one increases, the other increases perfectly, then you have a correlation of +1. And if one increases and the other decreases perfectly, it's -1. So the correlations are pretty good, and we'll see more data on that. A big controversy here has been brain, and Gould, who's in that first sentence, 1981. He and I didn't agree on a ton of things, but the size of the brain does correlate to some extent with IQ, particularly the frontal lobes. And of course, we're going to look at heritability in terms of identical and fraternal twins in a bit. And the book uses a concept here that they didn't use earlier in the book to soften how strong the correlation is. People with higher IQs are healthier, they live longer. They also, I think, tend to be taller. Now, this is what worries the heck out of me. Scranton is an old city, and we used lead in our pipes back in the old days. And of course, Rome used lead pipes, and Flint, Michigan became famous because lead in the water. So thunder. So on the x-axis, you have blood lead concentration, micrograms per deciliter, and IQ scores. And boy, you hit 15 and above, and nobody has an average IQ. Now, should a society worry about that? That you are generating children that, because of an environmental insult, have lost IQ? Oh my, yes. We have every reason to worry about that. Oh boy, quite a storm blowing up here. So I hope the infrastructure bill goes a long way to eliminating lead problems. There were school buildings where staff had to go in the morning and turn on the taps at the drinking fountains to get the water out of the line that had been sitting there all night. Because when it sits there, it picks up lead. So you had to flush the lines like every day to avoid the school causing degradation of intelligence in its students. And school performance, of course, that is what it was designed to do, and it doesn't do a bad job. in those Army tests, they did a pretty good job. Occupation and personal income, particularly if you're low, it doesn't work out very well. And people who are higher do better. So there's IQ, the 95 to 110%, right around the mean. And then what IQs do different professions have from 2002 data. And you can see that different occupations have different ranges. And rest assured that college professors should be fairly bright. IQ and income, weekly wages, lowest versus top 20%, education and income, high school, 2-year college, 4-year college makes a difference, but so does the IQ percentile. The government really should fix this lead problem. And yeah, this is from that book that although he's using more recent data that I referred to. And unwed mothers, lives in poverty, ever incarcerated. Having a low IQ is associated with not good outcomes. Happiness is more complex. And that's that. Facets of intelligence. Is there such a thing as general intelligence? I tend to believe there is. In that book that your author and I both read, the G factor, Spearman proposed that, and the data are pretty darn solid. G represents general ability that you can apply in virtually any situation. But it's more complicated than that. You have fluid intelligence, GF, which tends to decline across the lifespan, crystallized intelligence, storing facts. I'm so chock full of facts, and those are nicely defined. I think the next page. Oh no, oh boy. How long does it take to solve these problems? There's a swimmer who's pretty slow on the reaction time. She could have been concentrating on something else, but reaction time in different assessments can be correlated moderately well with IQ. And multiple intelligences, this is where Sternberg has done stuff, and his data are pretty solid. He's done good science, and he's got analytical intelligence, practical intelligence, or street smarts, and creative intelligence, triarchic abilities test. The Scrantonian is Gardner. Gardner didn't do a lot of science. He read a lot of stories. And from these stories, he came up with his theory of multiple intelligences, and there it is there, 8 intelligences, 1999. It's a good story, but the data from Sternberg is much more scientifically founded. It has a scientific foundation, and I believe in that. I think Gardner may have gone a bit far. And we used to have a Gardner school in Scranton. We probably still do. it appeals to parents. It markets well, but I want to see the science. And now we have intellectual disabilities and different degrees of disability and what people can do. And we've already seen Williams and syndrome and also Down syndrome. So you have Fragile X on the left and Down syndrome on the right, and those faces are very characteristic of those conditions. I still believe in faces in the brain. And fetal alcohol, I have them in my lecture too. Autism is less clear. And Mark Breedlove says, in my experience, many college professors, myself included, show at least some autistic qualities. I'll put my hand up there too. No doubt about it. Now, savant syndrome, we've seen already. We've seen examples of memory savants and artistic and musical and mathematical savants. We don't fully understand these. They do exist. I'm sure they're important. The Flynn effect is interesting. That IQ scores have been increasing over decades. So those are data going back to like 1918, after the flu pandemic. And that 18 was the flu pandemic. And then as we go towards today, standardized test scores have gone up quite a bit. Why? Good question. They're still working on it. Declining with age. Total IQ, it declines. Verbal ability hangs in there. Performance or fluid intelligence really takes a hit. And there's that. Group differences in IQ. Now, this was a big thing in the textbook, or the book that both Mark and I read. And now we're talking about heritability. Is it heritable? And we do what we did before, monozygotic and dizygotic. And the correlations are monstrous. But he does a calculation that he didn't do before and comes up with a heritability that's not quite so crazy of 0.54. But that's still way up there. Can you change it? And again, a big thing here is early education intervention. And if you want a country populated by people who are cognitively functional, I think the data are pretty clear that we can do that, but you have to throw money at it. You can't have people taking care of children who are less well paid than people who work in McDonald's. You need you need well motivated, bright people. And cultural bias, that's a big deal in terms of group differences. And here's an intelligent discussion of what's fair and what's not fair. And then we're discussing heritability again. And the earlier discussion is important, and this discussion is important. And the heritability of something doesn't mean it's written in stone. It's percent of variance accounted for. This is what the heritability of IQ does not mean. And it gives an example, and then there's a nice example here of, I forget the name of the plant, plants grown in different soils, yarrow plants, and there's an interaction. The environment affects different genetic potentials in different ways. Breastfeeding, breast milk is very complicated, and it evolved for people. There's a story of anthropologists in the rainforest of Brazil or something, and they were sitting around the fire drinking, knocking back some blood beer where they bled animals and fermented it. And then the natives asked the anthropologist, what do you guys drink? And he said, well, a lot of times we drink milk. And some of the natives just turned from the fire and vomited at the thought of taking milk from a cow and drinking it. So there are some data indicating interactions between environments and biology, and it's complicated. It's complicated. It's complicated. And PKU we've already dealt with, and I think we test for PKU by law, and it's so easy to fix if you know the problem is there. Why if something's heritable, why does it vary across groups? And there are data going back to 1970, IQ scores, shrinking racial differences in IQ scores at the end of the 20th century. So those are WISC scores, and things are changing. Can't change your genes, but we can change your environment. Heritability estimates are higher in middle class and affluent populations than poor people. This reminds me of the enriched environment research. You raise people in horribly restricted environments, and they just get nailed. But you put them in an environment where good things at least sometimes happen to them, and they're more likely to flourish. And yes, experience matters. Several studies have confirmed that early intervention boosts IQs and improve the lives of children in poverty. Who wouldn't want that? And there's a nice discussion of that. Sometimes things fade, as is discussed in this chapter, but some interventions seem to work pretty well, and they seem to last, and the children who go through it are less likely to do socially inappropriate things, which is good for society. I mean, society needs to invest in its children. Don't make children go to school based on what's convenient for the faculty. Do what's appropriate for the children. And the Mozart effect was big a decade or so ago. It's largely bogus. I think the state of Georgia, the government got the governor got raptured by this and decided to give pregnant women in Georgia CDs of Mozart. That didn't help. Emotional state can interact. Stereotype threat is very real. You know, African American students, white students, race reported before test, rates not reported before test. It makes a difference. Expectations, self-fulfilling prophecies. And there's a 2x2 table. Mark Breedlove is a fan of these, as am I. And, you know, African Americans exposed to stereotype threat, higher blood pressure, decreased performance. So if you want to hurt someone, you can do it, but we shouldn't. NBAC, not solid data. It was popular. I don't think it's as popular anymore, but you can try and do it yourself. And that's the end of that chapter. And the course is like 2/3 over. The summer goes wicked fast. So thanks for dropping by. Intelligence and intelligence testing is a very important topic. And the statistics that are in this chapter are relevant to statistics and relevant to the standardized tests that we currently use. And you've virtually all been tested. So thanks for dropping by. I did not lose power.